Okay, so here we are on this question. So this question is not about solving the stated problem, but about understanding it. So this is kind of an understanding question. A rocket is launched and its height above sea level, excuse me, t seconds after launch, excuse me, is given by the equation h of t equals that. From what height was the rocket launched? So question A, from what height was the rocket launched? Now, I know this, just reading these words probably seems like, what in the world? This is kind of a crazy question is this? But let me help with that. First off, notice that this equation here, h, height, this is h stands for height, is an x squared equation. See it right there? It's minus 4.9 t squared plus 1800 t plus 280. So that's a U shape, and it's got a negative in the front, so it's a negative x squared equation, which means if you put it on an axis system, it looks like that, doesn't it? You tracking with me? I'm saying that here, let me do a better job at that. So I'm saying if you put this thing on an axis system, what you'll see is it looks something like that. And how do I know that? How am I observing that? Because right here, this is x squared, t squared, whatever, same thing. It's an x squared, t squared, whatever. That's just a letter. That could be any letter. But it's an x squared, and it's got a negative in the front, right? So we've learned in this section that a negative y equals negative x squared graph is a U shape upside down. It's a parabola upside down. Specifically, this is height equal negative 4.9 t squared plus 1800 t plus 280. This is the t axis and the h axis. So it's like x and y, except it's t and h. Same thing though. Okay. So what are they asking me on this question? From what height was the rocket launched? So this is the rocket. And from what height was it launched? Well, right here is the height at the launch. Why? Because that's at t equals 0. Do you see that? At t equals 0 is when it starts. T seconds after launch. So when t is 0 seconds after launch, that means at the moment of launch, doesn't it? So if t equals 0, that is the moment of launch, because t is how many, according to these words right here, t is how many seconds after the launch. So if it's 0 seconds after the launch, that means it's at the moment of launch. So this point right here is over 0 up some height, h, right? And that's the height. That's what they're asking us for. What's the height at the launch? So we would need to find this point. What do you call a point like that? Well, it's an intercept point, right? Whenever you have a point that's on one of the axes, that's an intercept point. That's an H-intercept. So this is an H-intercept point. So right now in this question, they're just asking us for the names of things. In the next question, we'll have to actually solve them. So how would we actually solve it? We would plug in 0 for t, and you can see the answer would be 280. The rocket started off at 280 feet at launch. Then the next question, what is the maximum height the rocket reaches? Well, that's right up here. Here's the max. And that maximum has an x coordinate, well, not x, it's t, has a t coordinate and an h coordinate. It's over at some time, up at some height, isn't it? So the height is the h coordinate of the vertex. Remember, this point right here is the vertex of the parabola. Remember, the center of a parabola is called the vertex. The center of a parabola is called the vertex. So the center of the parabola is where you get the maximum height of the parabola. And the H coordinate is the height. The T coordinate is the time when the rocket is at its maximum height. So whatever time that is, the rocket reaches its maximum height. So what they're at, well, what is the maximum height? It's the H coordinate of the vertex. This is in your notes. Let me show you. Here's time. Well, here's the first one we did. This point right here is the height at the start. Plug in T equals 0. That's called the H-intercept, because this is the H-axis and the T-axis. So that's the one we just did. We answered H-intercept. This is the notes. I'm showing you the exam 2 notes here. This is the exam 2 notes that is at the top of the Unit 2 module. I just updated them. I just sent you a new copy. I'm always updating them. And then, so the second question about the maximum height is right here. Time and height at the max, right here. The max height, there's the time, that's the time. Plug in T to find the height. The height is the H coordinate of the vertex, as we just said. It's the H coordinate of the vertex. And we're not, so again, right now, this question is just about words. It's not about actually finding anything. Well, on the next one, we'll actually find it. How do you find a vertex point, by the way? Well, we learned a formula. X equals negative b over 2a. So that's what we'll have to do on the next problem when we want to actually find that vertex point, is we'll have to use the formula we were using for the other parabola graphs, the U-shapes. To find the center, the vertex, you got to use x equals negative b over 2a. But that's for another problem. And then finally, part C says, if the rocket will splash down in the ocean, when will it splash down? So here's the splash down right there, right? It splashes down right there when it hits a height of 0. It hits the water. So the splashdown, notice that the splashdown is hitting the t-axis. In particular, it's the t-intercept, isn't it? Remember, any point, like this point and this point, any point on an axis is an intercept point. This one's an H-intercept, this one's a t-intercept. And that's what I'm saying in the notes right here. At ground, height is 0, t-intercept right there. That's the t-intercept. So that's what they want from us answer-wise here. They want t-intercept. And so that's, those are the words. And how would you actually find that? Like on the next problem, I want to actually find it. You just let h be 0 because the height is 0, and you solve for t. Because the height is 0 when it splashes down. Find the time when that happens. When will the splash happen? So we'll do that on the next problem. For now, they just want those words. There we go. Questions on that one?